So today I will talk about our first data science internal section A and section B, analyzing student feedback data. This presentation explores key statistical methods for analyzing student feedback, focusing on dispersion, central tendency, similarly and dissimilarly measures. So now let's talk about the statistical measures for dispersion. Understanding the spread of data is crucial in student feedback. Beyond basic ranges, several measures help quantify dispersion, revealing the consistency of variability in response. So, variance. What is variance? Variance is measures how far each number in the set is from the mean. A high variance indicates that data points are spread out, while a low variance suggests they cluster closely around the mean. Standard deviation, the square root of variance, providing a more interpretable measures of spread in the original units of data. It indicates the typical distance between data points and the mean. Interquartile range, IOR. So the range between the first and third quartile, question 1 and question 3, representing the middle 50% of the data. It's robust to outliers and provides us a clear picture of central data spread. So now let's talk about efficient computation in large databases. For large databases, efficient computation of statistical measures is a crucial. Data functionalities and algorithms approaches can significantly speed up these calculations. So let's talk about database functions. Modern SQL databases offer built-in functions where std dev and percentile function, percentile count, NT, for direct computation on column, optimizing query performance for large tables. Approximate algorithms. For very large streaming data sets, algorithm like reservoir sampling and T-digest can provide approximate quantitative and other quantities with reasonable accuracy and significantly reduce computation costs compared to extra methods. So let's talk about faculty monitoring effectiveness rating. Let's analyze sample data of 25 students rating on the faculty mentoring effectiveness to understand various statistical indicators. These data are from 15 to 70. You can read it out. So mean and median. The mean rating is 13.56. The median middle value is 26. Mode and modality, the modes are 25 and 35. The data is by model. Mid-range, the mid-range average of min and max is 15 plus 70 by 2 is equal to 42.5. Quadliers, the first quadlier, question 1 is 21. The third quadlier in question 3 is 35. Now let's talk about five number summary and box plot. The five number summary provides concise overview of data distribution visually represented by box plot. Five number summary: minimum 15, first quadrant 21, median 21, third quartile 35, maximum 70. Box plot visualization. The box plot clearly shows the central 50% of the data, the median, and the potential outliers, offering insight into summary skewness. Now let's talk about quartile plots versus quartile and quintile Q to Q plots. These plots help in assessing the distribution of data but serve distinct purposes. Quantile plot plots the ordered data value against their theoretical quantities, e.g., percentile of the observed data. It helps visualize the shape of data distribution and identify any unusual observation. Now, quartile versus quantile, Q to Q plot, compares the quantile quantiles of two distribution, e.g., observed data versus theoretical normal distribution. If the data follows the theoretically distribution points will lie on a straight line, making it excellent for testing and distributor assumption. Approximation median for grouped scores. When data is grouped into intervals, we can estimate the median satisfaction score using cumulative frequencies. So here it is the table. You can read it out. Total students 3194. The median position is at 3194 plus 1 by 2. It's 1597.5. This falls into the range 21 to 50. Scores range cumulative frequency 950 to 2450. Using the formula for approximate median is group data. The approximate median satisfaction score is 136.8. Now let's talk about student age and learning productivity analysis. Examining the relationship between student ages and learning productivity reveals interesting pattern. So what are the key metrics? Here it is age mean 4.6 years, median is 52.52 years, standard deviation is 11.8 years. Productivity mean is 29.5%, median is 30.2%, standard deviation is 8.6%. Visual analysis. Box plots for age productivity shows their respective distribution and potential outliers. A scattered plot would illustrate if there correction between age and productivity, while a Q to Q plot would assess if their distribution aligns with a normal distribution. At last, I will talk about dissimilarity between student and feedback profiles. Measuring dissimilarity helps in grouping similar student or identify unique feedback. Nominal attributes. Use simple matching coefficients or Jaccard coefficients. If departments are different, dissimilarity is 1. If same, 0. For effectiveness, count matches. Asymmetric binary attribution. Focus on positive matches for attended workshops, yes or no. Use Jaccard's distance, which ignores cases where both are no. Numeric attributes. Employ Euclidean distance for overall magnitude differences or Manhattan distance or different distances along individual dimensions. Normalizing attributes for scales vary. Example CGPA versus attendance percent. Term frequency vectors. For open text feedback, keywords use concise dissimilarity 1 to concise similarity to measure angular difference between vectors and indicating topical similarity regardless of the slash name. Thank you for this video. I will come back in next video soon.